Secure Socket Layer or SSL Protocol. This is the overview of SSL Protocol. Overview: History, SSL roles, protocol stack, the four protocols, the record layer, message authentication code, handshaking, change, cipher, spec protocol, more handshaking, alert and application protocols, benefits and drawbacks. This is the history of SSL protocol. History: Need for secure web communication. Netscape. Word especially about credit card transaction over the web. Also worried about case of implementation since they wanted this to be industry standard, not proprietary. SSL version 1, 1994. SSL version 2 is also released in 1994. SSL version 1 wasn't widely implemented. Rules for establishing secure connection. Rules for public key encryption. Optional certificate-based authentication for servers and event clients. Flexible. No specifically required encryption, compression, or key generation algorithm. SSL roles. Two roles, client and server. Client: initiates communication, lists possibilities for choices. Server: listens for client connections, chooses from possibilities sent from clients. Both roles simply add secure socket layer to protocol stack. The SSL and the protocol stack. SSL between Transmission Control Protocol or TCP layer and application layer. Actually, there is two layers. This is the record and secure application. Can run under any protocol that relies on TCP including HTTP, LDAP, POP3, FTP.
The four upper layers protocols. Handshaking protocol. Establish communication variables. Change cipher spec protocol. Alert to a change in a communication variables. Alert protocol. Message important to SSL connections. Application encryption protocol. Encrypt, decrypt application data. Record layer frames and encrypts upper level data into one protocol for transport through TCP. 5-byte frame. First byte protocol indicator, second byte is major version of SSL, third byte is minor version of SSL. Last 2 bytes indicate length of data inside frame up to 2 raised to 14. Message authentication code. MAC secures connection in two ways. Ensure client and server are using same encryption and compression methods. Ensure messages sent were received without error or interference. Both sides compute MAC-S to match them. No match equal error or attack. Handshaking messages. Client hello, server hello, certificate, server key exchange, certificate request, server hello done, certificate, certificate verify, client key exchange, change cipher spec, finished. The process begins. Client sends client hello, highest SSL, version supported 32 bytes, random number, session ID, List of supported encryption methods. List of supported compression methods.
The server response. Server sends server hello. SSL version that will be used. 32-byte random number. Session ID. Encryption method that will be used. Compression method that will be used. Server authentication. To authenticate server, server sends certificate. Server's public key certificate. Issuing authority root certificate. When client receives certificate, it decides whether or not to trust server. This is only a step that might involve user if user never specified whether or not trust issuing authority before. Still shaking sends. Server sends server key exchange and information necessary for public key encryption system. If server wishes client to be authenticated, server sends certificate request message. The client will respond to this with a certificate message encrypted with a server public key. Server sends server hello done. Client response. Client sends client key exchange. Information necessary for public key encryption system encrypted with server's public key. Compute secret keys using key derivation functions such as Diffie-Hellman. If client is being authenticated, client sends certificate verified. Digest of previous message encrypted with client's private key. Change cyberspace protocol. A special protocol with only one message. When client processes encryption information, it sends change cyberspace message. Signals all the following message will be encrypted. Change cyberspace is always followed by finish message.
The end of the beginning. Upon receipt of change cypherspec, server send its own change cypherspec and finish message. After both client and servers receive finish message, handshaking phase is over. All following communication is encrypted. Encryption and compression methods can be changed with new change cypherspec message. Alert and application protocols. Alert protocols always 2-byte message. First byte indicates severity of message. Warning or fatal. A fatal alert will terminate the connection. Second byte indicate preset error code. Secure connection and alert not always used. Application protocol is HTTP, POP3, SMTP, or whatever application is being used. Simply give a datagram to the record layer. Benefits: ease of implementation. For network application developers, as easy as implementing unsecure socket. For network implementation developers, simply add layer to establish network protocol stack. For users, only need to authorize certificates. Drawbacks: more bandwidth needed, slower, needs a dedicated port 443 for HTTPS, assume reliable transport for underlying transport protocol, no UDP, implications for streaming media, VoIP or VoIP. The summary is need for secure communication, Netscape issues SSL spec, the four SSL protocols, message authentication code, handshaking, alert and application message, benefits and drawbacks.